Hello everyone and welcome to MV Tutors. I'm Tilo and I'll be looking at statistics that is covered in grade 12. Okay, we're going to start off first with a little bit of revision because like I've said before that maths is a cumulative subject, meaning that whatever you have learned in grade 9, 10, 11, 8 even, it comes back in grade 12. Okay, the assumption is that you know what you've learned previously and you can apply it at any time. Alright, so before we even begin, please don't forget to like our videos as well as subscribe to our channel. And if you'd like to have private lessons, please visit our website at www.mvtutors.co.za and you can book a lesson with us. Alright, so yes, with our revision, we're going to start with how we can plot the data that we get. Okay, so on the left, I have the plot of the data, and on the right, I have the box and whisker diagram. And I hope you remember the box and whisker diagram. Okay, we're going to go through it. So you have symmetrical data firstly, then you have data skewed to the left, and you have data skewed to the right. But let us see. So if you have symmetrical data, okay, basically the tail on the left and the tail on the right, they're basically equal, the length of it, right? And also, when you get the middle values, you will see that your mean, which I've represented with the X bar, is equal to your median, which I've represented with the Q2, which is also equal to your mode. Remember what your mode is? Is the number that occurs most frequently. Okay, so that is when you would have symmetrical data. And if you were to plot a box and whisker diagram for it, okay, firstly, here number one, you would have your your minimum value. Okay, then here at number two, you would have Q1, which would actually, it represents the first quartile. Then at number three here, we have the second quartile, which is Q2, also known as the median, which is the middle number. Please don't confuse the median with the mean. The mean is just the average of all the numbers, but the median is the middle number. So if you were to have data sets, like for example, if you have 5 data sets, you would know that 3 is your median because it's in the middle. But if you were to have 6 data sets, then 3 and 4, you would take that and divide it by 2 in order to get your median. Okay, so that's pretty much that with regard to the median, which is the second quartile. All right, and then we get to number 4, which is your upper quartile, which is Q3, all right, your third quartile, and lastly, your maximum value. So what you would do if you have your data set, you would arrange it in order from the minimum to the maximum. And by plotting the whisker diagram, you would show your minimum, your maximum, okay, and then your first quartile, your second quartile, as well as your third quartile, your lower quartile, your median, and your upper quartile. All right, so that is how you would plot the whisker diagram. So you can represent your data here in terms of a graph, or you can use a box and whisker diagram. Okay, and as I've said, when the data is symmetrical, the median, the mode, and the mean will be the same. Okay, but most textbooks would refer to the median being the same as the mean. Okay, they compare the mean and the median. They don't talk so much about the mode. All right, so now we get to data that is skewed to the left. Okay, so how do you know, because sometimes I also get confused, like how do you know if your data is skewed to the left or is skewed to the right? Don't look at where the peak is. The peak, you can see that it's more to the right. Look rather at the longer tail. Okay, remember when I spoke about it being symmetrical, I said that the tail on the left and the tail on the right are equal in length. But if it is skewed to the left, then the tail on the left is much longer. Okay, so that's how you know that it's skewed to the left. Okay, and sometimes they would refer to skewed to the left the same as negatively skewed. Okay, so they can use either terms. And as you have a longer tail or longer left tail on the box and whisker diagram as well, you would see that the bigger space is on the left rather than the right, and that's how you know that it is left skewed. So one thing to also notice about this data that is skewed to the left is that when your mean, or if your mean is smaller than your median. Okay, so where would you have your median? Your median, you would have it there at the peak. Okay, hence I've represented it with the Q2, and your mean actually lies to the left of your median. So if your mean is smaller than your median, then the data is skewed to the left. So if you were to calculate at some point, maybe you don't have a box and whisker diagram, or you don't even have a graph to show, you can use that knowledge to say that if my mean is smaller than my median, I know that my data is skewed to the left. Okay, and your median is actually closer to your upper quartile being Q3. Remember that on the box and whisker diagram? Q3 is your upper quartile, Q1 is your lower quartile. Now, what happens when the data is skewed to the right? Okay, again, we look at the longer tail. So when the longer tail is on the right side, then you know that it's skewed to the right. Okay, you can even see on your box and whisker diagram that the majority of that space there is on the right, not on the left. Okay, and in this case, well, if the mean, okay, that is x bar, is bigger than the median, which is Q2, then the data is skewed to the right. Okay, and in this case, the median would be closer to the upper quartile, which is Q1. Okay, so that is it with the box and whisker diagrams, and normally you would refer to all this data set presented on the box and whisker diagram as the 5-number summary. So instead of saying, give us, the box and whisker diagram values, they would say, please summarize the 5-number summary. Okay, so give us the 5-number summary, and you would remember that as your minimum, first quartile, second quartile, third quartile, and your maximum values. Okay, firstly, put them in ascending order from your lowest to your maximum. Okay, sort out your data before you start criticizing it or evaluating it. Now, terms that you need to be aware of. So we have your mean, median, and mode. Those are measures of central tendency. Okay, so this was covered in grade 10. Your mean, like I said, that's like your average. Okay, so we indicate it with the X bar. So if you have 5 data sets, you would, write them down. 1, 2, 3, 4, 5. And then what you would divide by is the number of your data sets. That's basically what the mean would be. That is the average of your values. Okay, the nice thing about calculators these days is you can plug your values in the calculator, and then I'll show you how to do it, and then you can just click on some buttons and it gives you the mean, so you don't have to go and calculate all of this, because it does take time. Your median, well, we've discussed that. That's more of your second quartile. That is basically the middle number. Okay, and I showed you, like in this case, if you have 1, 2, 3, 4, 5, your middle number would be 3. Okay, but if you had 6 data sets, then your middle number would be 3 and 4. So if you were to get your median, in this case, you were to take the average of those numbers. So 3 plus 4, which will give you 3.5. Okay, so that's how you would get your median. And then your mode is the frequently occurring number, the most number. So again, if you have a data set and you have a lot of 2s, then 2 would be your mode. Okay, so yeah, that is the mode. Then your range. Basically, your range would be your maximum value minus your minimum value. And then you can see the range of your values. Okay, then you have the interquartile range. So here it says interquartile. Okay, so interquartile would mean that you would take your upper quartile and subtract your lower quartile, hence interquartile. Okay, so Q3, which is like at 75% of your data, and Q1, which is like 25% or a quarter. You would say 3/4 for 75% or 1/4, 25%. But yeah, basically interquartile. Okay, so that would be Q3 minus Q1. And then we get to percentiles. So percentiles, okay, like I've indicated, that Q3 would be the 75th percentile. Q1 would be the 25th percentile. So when you've put your numbers in order, you can get your percentiles. And then there's this thing called ranking, okay, which is very important for you to put your numbers in order. Okay, so that you can say, I would like to know which value ranks as the 10%. So the equation for ranks would be R is equal to whatever percentile that you're looking for, okay, over 100. All right, if you have maybe 75%, you're going to say 75 over 100, or you could just say 0.75 and there won't be any 100 you need to put in there. Okay, but let's just stick to this. So let's say 75th percentile, you would put 75 where P is, all over 100, and then you have N, which is the number of data sets that you have. If you have like, I don't know, 15 data sets, you put 15 there, minus 1, and then you add a 1. So it would tell you the ranking. So if you were to put, if you wanted to know where exactly is 10% on your data set, you would put 10, okay, over 100, and N would be maybe you have 15 data sets, not data sets, but in your data set you have 15 values. So you'd put 15 there, and then it would tell you where your 10% or percentile is. Okay, so you use R for ranking. Okay, now we get to histograms and the frequency polygon, as well as the cumulative histogram, which is also known as the ogive. Okay, so basically a histogram, you are presenting, let's say they give you a certain count. For example, I've put their count versus height. So you have 5 people, 1, 2, 3, 4, 5, and then they said this is a family. You have your dad, the mom, brothers and sister, okay, and you want to know the height. Okay, you measure the height, and okay, maybe not a good example. This count would really represent, let's say you are taking the heights of people in a certain school. Okay, so this would represent maybe the grade 8s, 9s, 10, 11, 12, or whatever. But basically, you'll be counting there to say this certain people have this certain height. Okay, yeah, so basically that is what that would be. So here maybe you'd say I've looked at maybe 100 people, 80 people, and all the way to 0 people. Okay, and then here you have a range of heights. Okay, so you say from 1 meter to 1,2 meters, and 1,2 meters to 1,3 or 5 or whatever, but people are not that high. But anyway, the way I've placed it is yeah, it's not really in order, but that is what you would put on a histogram. Okay, all that data, and you count people that fall within that range. Okay, so at the bottom there you would have ranges actually. Now, a frequency polygon, basically once you've plotted your histogram, you go to the center, because the histogram is like blocks, right? You go to the center of the block, and then you just put a line graph there, but it's straight lines between points. Okay, so it's not going to be a curvy data set type thing. You're just going to put straight lines, okay, connecting the dots. Okay, so that's basically the frequency polygon there, whereas the histogram, it's just the purple blocks. Now when we get to an ogive, basically you would have your histogram, right? If they say cumulative histogram, you're going to take your data set. So let's say here the first one we had 100, second one there 60, okay, and the third one there it's like 120, and that is like 40, and maybe that's like a 75 or something. Okay, so what does your cumulative histogram do, or your ogive? Well, you basically start at 0, okay, because at 0 there's no count. There's a count of 0 there, okay, and then you start with your first value. So we know the first value is 100, and then you keep adding to it. So you're gonna add 60, so this value would then now be 160. Then we add 120 to it, so that would be 280. And now we add 40 to it, so that will be 320. And then we add 75 to it, so that will be like 395. So it's cumulative. You keep adding as you go along. But you would have to start first with your histogram, and then start adding the values because it's cumulative. Okay, so what does an ogive do? Like I said, you always start with a count of 0. So it starts there at 0. And then ogives are very useful for determining the 5-number summary of data and percentiles. Okay, so if you want to do your box and whisker diagram, you can actually get it on the ogive. Okay, and then another thing, when you're connecting the dots for your ogive, it must be straight lines. It won't be a curve. Okay, so that's how you normally draw it. I have seen, however, ogives, where people have tried to make it all curvy. Okay, I guess it's okay, but according to, textbooks, we must do straight lines in between the points, or to connect the coordinates. So that's basically that with the ogive. Okay, and with your count here, you could have it in a percent if you want to, especially if you want to go and determine the percentiles for one. Like we said, you can plot your box and whisker diagram using the ogive, or you can actually determine the percentiles. Okay, so that's a nice thing about an ogive. And then the last two bits of measures of dispersion. Okay, like I didn't say it there, but your mean, median, and mode, that is the measure of central tendency. Your range, interquartile range, as well as percentile, that is measures of dispersion, which we are continuing with here, which they like asking in exams in grade 12. Variance, not so much, but standard deviation, they do. So basically, variance is the average squared distance between your mean and each data value. So if you have your mean there, let's say your mean is 30, okay? So let's just draw a line. And then your data set, you have maybe 29 and then 32, and then like a 15 there and 60, whatever. So basically, the variance is the average squared distance between your mean and each data value. So you're going to take the distance between your mean and your data set value, and you're going to square it. So it's always going to be a positive number because you're squaring it, okay? And the unit for variance will be, if maybe your data set is in, getting heights, so it's in meters, so your variance will be meters squared. Just one thing you should be careful of, or remember rather, that your variance will be unit squared. Then we get to standard deviation. So what is standard deviation? It's basically how spread out values in a data set are around your mean. When you think about standard deviation, think about precision. Let's say you are taking data sets, you're measuring something in physics, you're trying to, determine what, but the values that you get, when you compare them to your mean, like they are off. You really have a high standard deviation when your values are off, and that's not really good. If you're presenting a paper and you've measured something, and you want to show how precise your measurements are, you do not want your standard deviation to be high. You want your standard deviation to be as low as possible, because the lower it is, the more precise your data set is. But the higher standard deviation is actually not a compliment. It's not good. Nobody will take your research seriously. So here, if values are similar, then the standard deviation will be low. Okay, so it is quite precise here. If values vary highly, so they're highly variable, then your standard deviation will be high. Okay, the data is spread out, and that is not nice because you can't really make a clear-cut conclusion. Okay, maybe something is wrong with your measuring instruments, or maybe whatever it is that you're measuring is really so variable that you can't make conclusions to it. There is no correlation. Okay, so and again, your standard deviation is always positive. Why? If you look at variance is that squared. Okay, standard deviation, you're just going to take the root of variance, so you can't have a negative value. It will always be positive. If you get a negative value when you're calculating standard deviation, then you're doing something wrong. Okay, and with standard deviation as well, there's a long calculation to do, but thank God for calculators. We can do it quite quickly. Okay, let me get the calculator out and show you how you actually get the mean, the standard deviation, the variance, your minimum, your maximum values. Okay. Okay, so the screen is going to be a little wobbly, but I just wanted to show you through the Casio calculator how you're going to enter your data. Okay. Yeah, so you would click on mode, setup, and then you would go to 3. Okay, press 3 for stat. Okay, and if you have a single variant data set, okay, you're just gonna click on 1 for that 1 minus VAR. Okay, then you're gonna enter your data set. Let's say you have 1, and then click on equal, then 2, click on equal. This is in order, then 10, then 11, click on equal, and then 14 equal, 68 equal to 86 equal to, and then 99. Okay, so that's, yeah, highly varying data, and then you just say equal to. Okay, then you can just click on all right, then you're gonna say shift and then stat. I don't know if you can see it here, but stat is on number 1. So now you can see here, if you click on 1, it will show you, let's see here. Okay, yeah, so the type, we're on 1 variance. Okay, so AC again, so click 1, shift, okay, shift 1. So if you go to 2, it will show you your data set as you have it. If you go to 3, it will basically give you the sum of all your data. And then let's skip 4 for now. That's actually our interest. But if you go to 5, I've never actually seen what happens at 5. Well, it gives you a distribution, but that's not really what we're interested in. So again, shift 1. And then if you go to 6, it'll give you your minimum and your maximum. So that will actually help you to plot your box and whisker diagram if you have your minimum and as well as your maximum. But we are interested in 4. Okay, so 4, again, if you click on 1, it will tell you how many values you have in your data set. If you click on 2, that will give you the mean, which is x bar. Okay, and if you click on 3, that will actually give you a standard deviation. Okay, so let's click on 2. Let's see what the mean is for our data set. So it is 36,375. Okay, yeah, and then if we go and again shift 1, 4, and if we go and see what the standard deviation is. Okay, so remember our mean was what, 30 something and our standard deviation is 38. Okay, so yeah, but if you look at our data set, it is varying quite a lot. Okay, if you forgot, well, basically if you go back there to click on our data, I mean our first value there was 1. Okay, and then it went all the way, our last value was 99, which is 8 data sets. So it varies quite a lot, so it makes sense that the standard deviation is quite high. So if you are measuring something and you have an experiment, then yeah, that's not going to be such good news for you. If you have a standard deviation that's so high, it means that your data is not so precise. But that is what happens when you enter one set of data. We're going to get to the next section where we're going to discuss now what is done in matric, which is bivariate data, okay, where you have scatter plots. And in this kind of data, you're going to enter 2 types, okay. For example, let's say you want to know how many ice creams were sold on a particular day versus the temperature of that day. So when you want to enter data that has 2 sets, okay, again, you don't go to shift, you go to mode, okay, and click on 3 for stat. And then now you're going to go to number 2 where you see a plus bx, okay. And then here, once you know the values on the x-axis, which is the independent variable, and y, which is the dependent variable, you're going to enter your data set, okay. And then once you enter a data set, let me just enter random values here, 55, 56, 89, Okay, and then on the other side, start from the top. 9, okay, equal to 23. This is very random. Oh no. Okay, so that is it, and I say AC. Okay, so again, if I want to measure anything, okay, I would go shift and then 1 for stat. Okay, same thing, I would go to 4, and you can get for number 1 how much your data set is, okay, or how many values are in a data set, and for 2 the mean. All right, and then you can also get the standard deviation for both the x and the y, okay, because you see the mean for your x-axis and the mean for your y-axis, as well the standard deviation for your x-axis, standard deviation for your y-axis. So it's quite useful. Alrighty, so you've seen how we can use the calculator to draw one kind of data set, okay, one variate data set, and also how to have a bivariate data set, or rather a scatter plot, okay, that you can do on the calculator as well. I showed you the Casio because the one that I have is not exactly a Casio, even though you do the similar thing, okay. So I'll use this particular one when we do the past paper question. All right, so what is bivariate data? Like I said and tried to explain, that's where you have data that has two things to talk about, two variables, all right? So you can then see, like for example, ice cream sales compared to the temperature of the day, and you're expecting that the colder it is, the least ice cream sales you're gonna have, and the hotter it is, you're gonna have more ice cream sales, okay? And also maybe looking at the coronavirus, you could say that during the winter times, you can see a lot of numbers rising, a lot of COVID cases as opposed to summer, but that can also change. I mean, we've seen because of summer, a lot of people, especially now in December, a lot of people are meeting up. Beaches, especially in Durban, I mean, there are like a lot of people there. So that can also be a spreader. So you could say that the more festive the season is, we're likely to see a lot of COVID cases. So it's quite important to understand how you can plot data, especially knowing which one falls on the x-axis, which is your independent variable, and the one on the y-axis, which is your dependent variable, and how you can then, after plotting this data, how you can then interpret it and write a report, for example, okay? So yes, now so once you have this two types of data, these two variable data, you're gonna plot it on a graph called a scatter plot graph, okay? Hence, I've written the scatter plot, okay? And basically a scatter plot, basically you're gonna like plot your data, okay? And as you plot it, you're trying to see, is there a trend here, okay? the data set that I have, it's quite, yeah, it's like all over the place. But for matric, you are only expected to look at linear trends, okay? So maybe you could say this is your line of best fit or something, but yeah, this kind of data is quite scattered. I mean, very scattered. That's not a nice data set to work with, especially if you need to conclude what is actually happening. Sorry about that. Okay, so now we're gonna talk, as you plot your data on a scatter plot, we're gonna look at the association, okay? So with association, it means, is your data set having a negative trend or a positive trend, okay? That's basically what I mean by association. And with that, if you were to plot, let's say you had a good data set, okay, let's say you had a good data set, and basically your data is doing something like that, okay? So when you go all the way from left to right, you can see that there is an increase. If you were to draw a line of best fit, there is an increase over here, okay? So this is a positive association, okay? And a negative association would basically do the opposite. So it does something like that, Okay, so the variables that you have here, we would say this is your x, this is your y. We would say that y is actually directly proportional to x, because as x is increasing, y will also increase. But here we would actually say that y is inversely proportional to x, because as y increases, or rather as x is decreased, y would increase. Okay, or when y decreases, x would increase. All right, so this would be a positive association, and that would be a negative association. Now we need to look at relationship. Okay, basically the strength or the weakness, and we're going to get into detail with that a bit later. But basically, if you look at the correlation of your data, if you have something like this where your data set is really close to the trend line, that is quite a strong relationship that you have here. But if you have data that is like all over the place, that is more of a weak relationship. Okay, and then the type of trend as well. Okay, so with the type of trend here, we're looking at the type of graph. Like I said, for matric and for examination purposes, they'll be examining you guys on a linear trend. Okay, as I've shown here for the positive and the negative association. So a linear trend is what you should be expecting, but there are other type of trends as well. Sometimes you can get a parabolic trend. Okay, parabolic, remember your quadratic graph, it would maybe look something like that, so it's quite parabolic. Or you could even get an exponential trend. Okay, yeah, exponential trend. I was actually looking for another term. Okay, but yeah, exponential trend basically starts out quite slowly but eventually has its peak. And I would say that whenever a new virus comes up, starts out like 1 case, 2 cases, next thing you know, 1,000, and next thing 1,000,000 cases, like we've seen with COVID. So yeah, that would be the exponential trend. But to keep things simple, very simplistic, for matric, we're going to stick to the linear trend. Much easier to deal with, and not the parabolic or exponential. I haven't seen a hyperbolic trend. I haven't yet seen it, honestly. And then we get outliers. So again, let's say you have your data set. Let's say it has a positive association. Okay, and it's linear and quite strong as well. Okay, and then randomly you just get these outliers. Okay, so yeah, basically sometimes you just ignore the outliers, but you should comment on it that we have a moderately strong relationship. The association is positive, but we could see or note a couple of outliers. Okay, when you describe what you're seeing and what you've plotted. All right, and then groupings. Okay, so when it comes to groupings, it's more of, let's say you have a data set where you have data just in the middle. Okay, and then there's like a gap, and then it just continues. So here you have two kinds of groupings. Okay, and what you would do then, okay, once you have a trend line, okay, so here we also have a linear trend, which has a positive association. So once you have this trend line over here, what you could do is interpolate. Okay, because you would have drawn your line of best fit. Okay, so this is your line of best fit. Okay, but before you draw a line of best fit, what you're going to have to do here is pretty much interpolate. So you see this data missing here, in between here. So you would extend that data set, and we would have to refer to that as interpolation. Okay, we're going to discuss that a bit soon. But you see the data set is grouped. We have an upper part and a lower part. So for you to get the in-between, you would interpolate it. If you wanted to see what would happen in the future, you would extrapolate it. Or if you want to take it back to the past, you would also have to extrapolate. Okay, extrapolate the data. But we'll talk about that in a few. And basically then you can then draw your trend line and, do that. Something like that. Now let's talk about the correlation coefficient, which we related to the relationship, whether you have a strong data set or a weak one, okay, once you plotted it. So basically when you have, the correlation coefficient we indicated with a value called R, okay. And with that, basically, if R is equal to 1, that would really indicate that you have a perfectly positive data set, if I could say, or correlation, okay. So if R is equal to 1, it would be perfectly positive, okay. Correlation, it means that it is quite strong. It means that when you plot your data set, honestly, the data that you have and the trend line that you drew, or the correlation line, maybe something like that, it is quite accurate, okay. It's quite accurate. You can trust the data set. So if you were to extrapolate it or interpolate it, you would trust the results. So that is perfectly positive correlation, okay. If we get R between 0.8 and 1, we would say that it has a strong, okay, let me just say strong. It has a strong positive correlation, okay. And a value between 0.5 and 0.8, well, it would be moderately strong, okay. Moderately strong positive correlation, and 1 between 0 and 0.5 is a weak correlation, okay. Yeah, weak correlation, weak positive correlation, okay. And if you ever get one that is actually 0, then there is no correlation at all, okay. So it depends. Like I said, you have your graph over here. A positively strong one would really create a straight line for you, like this is positively strong. And then once you get to the strong, you have some bit that are out there. But once you get to weak, honestly, like your data set is quite everywhere. Okay, there is really no correlation there. So that is what I mean. And then the true is the same is true for the other side with the negative. This would be perfectly negative correlation, okay. And again, if we go from -1 to 0.8, it would be a strong negative correlation. And from 0, no, something is missing here. Negatives are missing. So if you have -0.8 to -0.5, that would be a moderately strong negative correlation. And -0.5 all the way to 0, that would be a weak negative correlation. Okay, so if they were to ask you, okay, fine, you calculated the R value, which is the correlation coefficient, what would you say about it? Just comment on the strength, okay, and also comment on whether it is positive or negative, okay. Sometimes you get no correlation whatsoever. If you do get such, it's maybe your data set that does this, that's quite horizontal, or your data set that's quite vertical, which would be weird, but there is no correlation for that kind of data set. So that is when your R would be equal to 0. Okay, and then we talk about the regression line. So the regression line, I've mentioned it before, is when you've plotted your data set and then you're going to draw a line of best fit. Okay, so you try to see from the data set that I have, what kind of linear trend do I have, and what would be the equation of the linear trend. So you have your data set, maybe somewhere here, your regression line would be that, okay. So the line of best fit, or they call it the least squares regression line. And because in matric we're only examined on the linear trend, this would be the equation. I hope it reminds you of y is equal to mx plus c. It's just the c would be the a in this case, the m would be the b. Okay, but yes, it's a straight line equation. Y is equal to A plus BX. And that is something that you should also see on your calculator. Let me just show you here. So if we went mode stat, then you would see, okay, we have one variable calculate, and then we have this A plus BX. I hope you see that you have A plus BX. You can plot your data on the X side and on the Y side. All right, so yes, the A would represent the y-intercept of the regression line, and B, that would be the gradient of the regression line. Okay, so that is the regression coefficient. And if you wanted to calculate what B is, you would you would take R, okay, and then you would multiply it by the standard deviation of Y over the standard deviation of X. And I showed you previously how to get the standard deviation of Y as well as the standard deviation of X. Now, because this line here, the regression line, it gives you the line of best fit for the data that you have plotted. It's not exactly 100% representative of your data, but it's a good estimate, okay? So we get to a term now that we call the residual. So the residual is the difference between the predicted value and the observed value, okay? Or the deviations from the line of best fit. Okay, so what do I mean by that? So you have your scatter plot, okay? And you have plotted your data over here. Okay, there's a lot of data. And then you plot your line of best fit. All right. Plot your line of best fit. And that is the line. And then, so if we say the predicted value, okay, so the values that are on this line of best fit, that would be represented by that Y with the copy over there. Okay, and then the observed or the actual values, these are your observed values, your actual values. Okay, so when we talk about the residual, we're basically talking about the difference between the predicted value as well as the observed value. So how would you then calculate it? Well, you would take the Y values only. We're not looking at the X values. So you would take the difference between your predicted as well as your observed, and that would be your residual. Okay. Yeah, and for a linear trend, your residual, actually, you'll have a mixture of negative and positive, and that shows you that it's actually a linear trend. Whereas if you had a parabolic or a linear, you would first see maybe negative values and then positive and then negative, or maybe positive, negative, and positive, but there's a trend. And if you see that you have a residual where you get negative values, then positive values, then negative values, you know you either have a parabolic trend or a exponential trend. Okay, but we're not focusing on that right now. Our residual for linear graphs, it would be all over the show, positives and negatives, and no trend in particular. Okay, then we get to, again, I said we'd explain it, interpolation and extrapolation. Okay, so what is interpolation? I'm just going to draw one graph just to indicate that. I tried to explain there previously. Okay, so again, let's say you have a trend over here, and then all of a sudden there's a missing data in your data set, or it appears as though it's missing. Okay, and then you have data again that continues. Okay, let's say this is the amount of years and some other variable. Okay, yeah, so now you want to plot your line of best fit. Okay, but there is missing data. Okay, so if you can see that, okay, here it's actually working out a bit, I can see a trend here, and I can continue with it, and I can see this is my line of best fit. All right, so you would get an equation for this line of best fit, okay, which is going to be Y is equal to A plus BX. All right, and by so doing, you can then use what we call interpolation to then close this gap over here. Okay, so this would be interpolation. And when you interpolate, okay, this is like the most it's trusted, right? Interpolation, well, you can trust the values there because you can see the trend generally was just going up over time, and then there was something happened there. You can query it, okay, and say, okay, what exactly happened there, such that there was a disturbance in the data set, and then it continued again. So you can trust the values there, okay. It's more accurate, okay, as opposed to extrapolating. So when you extrapolate data, okay, maybe when you extrapolate it backwards, it can be trusted a bit. But if you extrapolate onwards, because sometimes, especially in the financial market, people will come to you and say, listen, we are a good investment company to be with. We can show you the history, and over time we have been able to sustain this interest rate. It's good, our clients are happy. And I mean, when you hear that kind of information, you're like, wow, I want to invest with you guys. But little did they know that actually by the year 2008 there would be a financial crash. Okay, so this will not be the trend anymore. Okay, in reality, as it went up, well, because of the crash, everything went speedily down. Okay, so now there you are, you invested all your money and you put all your savings, and then next thing there was a crash and you lost all of it. So you can't really trust extrapolated extrapolated data, okay, because it can be inaccurate because you don't know what's going to happen in the future, okay, especially as well with the coronavirus. Okay, so let's just say there was a trend, it went on, it was good, but coronavirus, a lot of people lost their jobs. Okay, in other markets, I mean, when it comes to online things, everything was like great, but other businesses suffered. So you can't, like I said, you can't really trust extrapolated data. Anything can happen in the future. Okay, but if you're gonna backdate things, I think this kind of extrapolation, when you're backdating it because you saw what happened in history, you can sort of like trust it. Okay, I'm gonna put trust in inverted commas. You can trust it a little bit, but as for this one going above the extrapolation, not so much. Okay, and that's it with the theory for statistics. We're going to look at a past paper so that you can, put all that you've learned here to practice. All right, so I found a past paper. We're looking at the February-March supplementary exam from 2016. Ooh, it's getting so early. So yeah, we're going to look at question 1 and question 2 of paper 2. Okay, that's where statistics is normally tested. All right, so question 1, we have been given a box and whisker diagram. Okay, so the box and whisker diagram below shows the marks out of 80 in a history test by a class of 9 learners. Okay, so these are 9 results that have been plotted. Okay, now before we comment on the skewness of the data, which is question 1.1, I want us just to familiarize ourselves again and actually remember what is what. Okay, how do I get rid of this thing? Okay, great. Now, so this would be our minimum value, right? And that would be our maximum. Okay, this would be our median. Okay, I'm just going to say Q2. That is going to be Q1, which is the first quartile. Okay, the first quartile, which is a quarter, or we could say that it's 25%. And then we have our second quartile, which is like 2/4, which is the same as a half, which is the same as 50%. Oof, my handwriting there. 50%. And then we have our third quartile there, Q3, which is the same as 3/4. That's 75% of our data. So our minimum is 20, our first quartile is 32, our median or second quartile is 62, Our third quartile is 75 and our maximum is 80. All right, now let's see. It says comment on the skewness of the data. Now I told you, if you want to know whether something is skewed to the left or to the right, if you look at a box and whisker diagram, look at the side that has the most space. Okay, and just by looking at that, the left hand side has the most space, so it would be skewed to the left. Left skewed. Or skewed to the left, or negatively skewed. Okay, now it's 1 mark, so we're not going to go into that much detail. Now it says write down the range of the marks obtained. Okay, we did say that range is basically your maximum minus your minimum. And what is your maximum? Your maximum is 80. Your minimum is 20. So your range is 60. Range is not mean, okay? That is not the average, please. Okay, 1.3, it says that the learners had to obtain 32 marks to pass the test. Estimate the percentage of the class that failed. So if 32 is your benchmark, okay, so basically if you have 32 marks, okay, if you go above 32, you have passed. If you go below 32, you have failed. So it's saying estimate the percentage of the class that failed. Okay, looking here, basically everything in this direction. So everybody in this side here, they have pretty much failed. And because 32 is our first quartile, okay, it means that the percentage of the class that failed is actually 25%. Okay, because 32 was actually our Q1, which is 25%. All right, and then 1.4. In ascending order, the second mark is 28. The third mark, 36. The sixth mark, 69. The seventh and the eighth marks are the same. The average mark for this test is 54. So now we must fill in the marks of the remaining learners in ascending order. Okay, so let's see. We had 9 learners, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. So which is our median? Okay, so we have 4 on the side, 6, 7, 8, 9. You know, that's 4. And then we have 1, 2, 3, 4, and that's 4 values in our data set. So 5 will be the median. And our median, what is it? Our median is 62. Okay, so in between here, that is actually my first quartile. And between 7 and 8, that's actually my third quartile. Because for me to get Q1 and Q3, I have to half. So once I have the median, I then look at the data set on the left of the median, and I have to take half of that to get Q1. And on the right side of my median, I have to get median. I need to get half of my data set there. Okay, so now Q1, I already know that Q1 is 32, right? So the value there would be 32. And then Q3, it would be 75. And they already told me that the 7th and the 8th marks are the same. So yes, it would be the same. So I have 75 over here and 75 over there. Now I can put in my maximum and minimums. Okay, I have it. I know that the minimum was 20 and I know that the maximum is 80. Okay, so basically guys, all of this that I'm writing, you would then say, okay, Q2 in this case is 50, no, well, 50% is basically 62. You would then say Q1 is 32. Well, we don't really need to show that. I would actually then refer to Q3. Okay, Q3 is 75. Okay, and then we have our minimum and our maximum. That's already put there. So min is 20, max is 80. Okay, and that's the 9th, that's the 1st, that would be the 7th and 8th. Why did I have to play music now? And then 62, that's basically our 5th data set. Okay, so what are we left with? We are left with our 4th. So we have been given the average. Now we're going to calculate average the long way, but at least you know how to do that, right? So we're going to have 20 plus 28 plus 36 plus x, oh, maybe let me not say x, I'll say d, since d is like the fourth alphabet. Then we have 62, and then we have 69, then we have 2 times 75, and then we have 80. And we're going to divide all of that by 9 because there are 9 values in this data set. And they've given us the average that it's actually 59. So I have 54. 54. So I'm going to add all of these values up. Okay, let me go back to my normal mode. But yeah, I hope you're enjoying the background music. So we have 20 plus 28. It's actually not that bad. 36, 62, 69. We have 2 times 75, which is 150. And then we have 80. Okay, so we have 445, right? So 445 plus D over 9. If I say 54 times 9, what am I going to get? Okay, 54 times 9, that is 486. So I have 486 this side, and I have 445 plus D. Therefore, D would be equal to 486 minus 445. 6 minus 5 is 1. 8 minus 4 is 4. Yeah, so the fourth data set is 41. So we have 41 over there. And we have filled in the marks. I think this is kind of nice. All right, and then we're going to do question 2 in a bit. Let me wait for the music to die down. All right, the music has stopped. Question 2. A company recorded the number of messages sent by email over a period of 60 working days. The data is shown in the table below. So we have number of messages as well as number of days. Okay, guys, so this is still, when you plot it in your calculator or put in the data set in your calculator, it's still not a bivariate data set. It's just one, okay? But actually it is bivariate. What am I saying? It is bivariate, but there's a difference. So you have number of messages and you also have number of days. Which one is your independent? Which one is your dependent? Well, basically your number of days will be independent because days are just days. They're not, but this is not what we're really getting to here. What I really want to get to is the number of messages and the way that it's written. So if ever you have a data set where you have maybe 10 and then X, so you have, a number in between, and you're like, what are you going to put in the calculator? Okay, this is like a frequency. Okay, this is a frequency. Okay, and you would then put this, okay, let me not confuse myself and you too. So with this frequency, what you normally do, you get the number in between. So you're going to take the average of 10 and the average of 20, and you get 15. And you're going to do the same for all of them, okay? But when you plot it in your calculator, I will show you in a bit, you are not going to use the bivariate data set where y is equal to a plus bx. We're not there, okay? You would still use your 1 minus VAR, okay? So what you would do before doing that, because if you just do 1 minus VAR, it's just going to give you one column with X values that you should put in. But actually you shouldn't do that. What you should do first is you should go to shift mode, okay? And get to a point where you get to stat. Once you click on stat, there's a question that it asks frequency, on or off, and you're going to click on 1 for on, okay? Such that when you go to mode setup and you click on stat, you go to 1 minus variance, then you would have a column for x and a column for frequency. Okay, so this is what we're going to do. So what would be the frequency? The number of days would be the frequency, because your x would be, maybe for number 1 would be 15, and the frequency, how often does it occur, messages or emails, it'll be 2. Okay, so your frequency is 2, your second data, it would be 25, and then your frequency would be 8. Okay, so this is like a frequency polygon or frequency graph that you could plot here. We're not at the scatter plot where you're actually going to have a bivariate data set. That's what I wanted to get to. So here, for the number of messages and frequency would be 2 days. So firstly you would have 15, and then you'd have 25, 35, 45, 55, 65, 75. Why am I putting 78? Okay, 75 as well as 85. Okay, and this is your x that you would put in the calculator, and that would be your frequency. Okay, I'm gonna pause and then set up the calculator. I wish this one would work that way, but it doesn't, or maybe I don't know how to operate this calculator, but I'm going to show you with the Casio calculator. Okay, so my hands are going to be a bit wobbly, but basically when you go to mode and you click on 3 for stat and you go to 1 minus variance, you only have that one column for x, right? So what I'm basically saying is you're going to go shift mode. Okay, if you have a simplified Casio, you won't get all these options, but where you want to go is stat. So 4 is stat, and it asks frequency on or off, so you'll press 1 for on. Okay, then again you go to the mode and we go back to stat, and then we still go to 1 minus variance. We're not at the scatter plot where you have a plus bx, so we're just going to go to 1 minus variance, and then you have x values and you have your frequency. So we're going to enter those values. So we have 15, okay, 25, 35, 45, okay, 55, 65, 75, 85. Okay, and then okay, so the first value, I hope you can see. So we have there 15, 25, 35. So for 15 we have 2. Okay, then we have 8. Then 5. Then 10. And then 12. 18. 3. And 2 as the last one. So for 85 we have 2. Can you see it? Okay, we have 2 there. Yeah, so now for 2.1 it's 3 marks. Okay, so we're gonna have to do a calculation there, but if you're out of time you're gonna enter this data set in the calculator. So if you want to get the mean number, oh gosh, what did I do now? If you want to get the mean, okay, you're just gonna go AC and then shift 1 for stat, then you're gonna go 4 for variance, and then 2 for mean. So your mean is actually 51,333. That's the quick way to do it. I'm gonna show you the long way of doing it. Okay, so doing it the long way, please excuse my nails. I just realized that my nail polish is partly cloudy. Okay, if you're gonna do it the long way, basically you're gonna get x and multiply it by frequency for each line. Okay, so we're gonna have 2 times 15, 8 times 25, 5 times 35, all the way to 2 times 85. And then what's in your denominator? Basically you're gonna take the sum of the number of days. Okay, there's actually a formula for it. I'm not sure if it's in your formula sheet, but that is basically how you work with frequencies. Okay, so if you sum all the number of days up, it gives you 60, and if you sum all those products in the numerator, it gives you 3080. So we're going to use this calculator here just to get our answer. Let me just go to the normal mode. So it's going to be 3080 all over 60. And we get the same answer, 51,33333. Okay, 51,33. Okay, that's basically the mean number of messages sent per day, rounded up to 2 decimal places. Yes. Okay, so you know the short way and the long way. I would advise you do the short way for time's sake. Okay, now it says draw a cumulative frequency graph or an archive of the data on the grid provided in the answer book. Okay, so we don't have a grid here, so I'm just gonna try and do it. So how would you plot this graph exactly? I'm just gonna put the information in a table. Actually, what we can do is the number of days, they will be cumulative. So let me just put it, I don't have to, let's do it together. So cumulative frequency. Okay, so initially we have 2 plus 8 would give you 10, plus 5 you would have 15, plus 10 would be 25, plus 12 it would be 37. Yes, okay, and then plus 18 it would be 45 or 55. Yes, 55, sorry, 55. Okay, so I would have 55, 37 plus 18 is 55, plus 3 I would have 58, and then plus 2, 60. Okay, so then for my number of days, yeah, and then the number of messages. Okay, so let me just plot it quickly and then we will discuss. Okay, I have the graph paper and now let us plot. So on our y-axis, we have the cumulative frequency, okay? And on the x-axis, we have the number of messages. So we're going to start there at 10. We actually have 0. Remember with the archive, you started at 0. Okay, and at 20, we have 2 as the number of days. So 2 is going to be somewhere probably lower than that. I've plotted now 2.5. All right, and then at 30, we're going to have 8. So 8 is just there below 10. And then at 40, we will have 5. Oh, my goodness, I'm plotting the wrong thing. Okay, initially we have, sorry, initially we have 0, right? And then at 20, we have 2. Yes, that was a correct plot. Then at 30, we have 10. And then at 40, we have 15. Okay, this is plotting nicer. And then at 50, we have 25. So there is 25. At 60, we have 37. So 35, 37. Somewhere there. At 70, we have 55. So, oh, my finger is in the way. 70, we have 55. Okay. Alrighty, and at 80, we have 58. So 58 at 80, somewhere around there. And then at 90, we have 60. Okay, so 90 is there, so that's 60. And I told you that when you plot this graph, well, basically, you're going to use straight lines to do it. Okay. Let's see. Let us try. Okay, but if you want to fit in a curve, I guess you can. Okay, no, this is not going to work. Let me just try myself. Okay, let me start at the end there. Now I want to put in a curve. I'm tempted, but yeah, I guess you can put in a curve, but Some would say we put straight lines. Let's see if we were to put a curve, how it would be. A curve would actually look much nicer. Okay, so you would have something like, the only problem with the curve is not every point will fit nicely. Okay, but whatever, let's just stick to the, yeah, it's fine. It's okay, we've answered. Okay, so now let us see. We have drawn the archive, and now it says, hence estimate the number of days on which 65 or more messages were sent. Okay, the number of days is here. Okay, so if we have 65, let's draw that line showing 65. Okay, maybe let me use a different pen or color. Okay, let's use red to show. Okay, so 65 is here. Okay, I'm just going to draw it all the way. So that's the line for 65. So it says, estimate the number of days on which 65 or more messages were sent. Okay, so we're going to have a frequency there, it crosses 55. Okay, I would say that value there, so this is 45. Okay, so here we have 45. I would say maybe this is 48, maybe. I don't know. Okay, but basically what I'm gonna take is 60. So basically this space over here. Okay, so assuming that this is correct, if I were to say 60 minus 47 for 1, okay, that would be my answer. Okay, I think this value 47 is, yeah, yes, these things, guys, once you start plotting them, I'm gonna take that as 47. So 2.3. Okay, 2.3. So yeah, estimate the number of days on which 65 or more messages were sent. Well, I would say then 60 minus 47, and that would be 13. So 13 days. I hope when they mark this, they actually have a range of answers, because this would depend really on how you drew the archive. Okay, but other than that, guys, we are done with this question and we are done with this section. For more information, please do visit our website, www.mvtutors.co.za, and please don't forget to like our videos and subscribe to our channel. And while you're at it, click on that notification bell to get more notifications when we load more videos. Awesome.